It's part of what I do. I come from environmental science. My master was at Pontevedra University in Naples, where I also did my PhD. And I basically I work in environmental accounting. I use life cycle assessment and Emergy accounting, and that's what I did for my masters. And I continued for my PhD. And I'm very interested in this kind of integration between methods to understand if there is potential for like a more holistic view, a more holistic understanding on case studies and etc. And I've been involved in my PhD thesis was about the concept of circular economy. I've been involved in a lot of projects on circular economy, on energy efficiency, on waste recovery, etc. This was my PhD thesis, so we were like assessing circular economy strategies, the concept of circular economy and bioeconomy, and also these accounting methods and integration. The main point was this biorefinery concept that can be defined as the sustainable processing of biomass into a spectrum of products and energy. So my idea was that economy can lower its dependence on fossil fuels, on chemicals, on toxic substances by going back and using biological stuff like agricultural byproducts, farming byproducts, and that kind of stuff. And this biorefinery, in my mind, was not like in this image, like an industrial plant producing everything. It was more like a connection between different processes, different pathways, all exchanging materials and energy among them, mimicking what happens in the natural ecosystems. In the natural ecosystems, the concept of waste does not exist. Everything is used and reused until its value added is finished. It's no more. Now that I'm working with the engineering, in the engineering department, this kind of stuff, it's a lot less in my life. I'm working on energy generation systems. I'm assessing sustainable energy generation systems. This is one example. This kind of diagram comes from energy accounting. Maybe we can talk about that later, but just to show one of the systems I assessed recently. This is a geothermal system in Naples. It's all modeled, it doesn't exist, but it's modeled on the actual consumes from 8 buildings in Bagnoli, which is a neighborhood in Naples, and from data from geothermal well. So there was electricity production to be sold to the Italian grid of electricity, and then heating and cooling to be delivered to these buildings. There were like 8 buildings, 5 residential buildings, and 3 offices. And another system was this one called the Smart Mobility Hub. This almost exists. I mean, there's almost a prototype of this system, which is basically a container with solar panels, a gasifier, and an engine. And it will be used to produce electricity from agricultural byproducts. There's still some problems because for the Italian legislation, they count as waste so it's difficult to reuse them in another production process. But the idea is to use this vegetal biomass to produce synthetic gas to be burned in an engine, like a car engine, and produce electricity for giving electricity to electric vehicles in this area. This is to be placed in a national or provincial park. You know better than me. It's a provincial park. In the inner area of Cilento, which is in Campania region, it's an off-grid situation. So they have no electricity there. It's like very Montenusilli kind of situation. It's very disconnected. And the idea was to provide them with sustainable electricity for electric mobility.
Can I just quickly ask? Because
Yeah.
I don't think I completely understand. It would be, for example, for a car engine to feed back into the same car.
No, the car engine is part of the system.
But how does it connect to the grid?
No, it's not connected to it.
It's electrical.
Yeah,
Okay.
the engine would burn the synthetic gas produced by using the agricultural byproducts.
Okay, yeah, okay. So it is a
So
circular
there's an
system,
alternator
yeah.
and this kind of stuff. They will produce electricity to recharge electric
Yeah,
vehicles.
yeah, okay, yeah, that's one.
And it's completely off grid.
Yeah, yeah, yeah. Thank you.
Yeah.
So the gas, you get gas, and then these guys can be converted to electricity, no? That's
Yes,
the idea, no?
yes. You
But the
produce
gas, you
this
do it to stock it.
Why don't you use the gas to run the car?
because the idea is to use electric cars. Because this kind of gas, this synthetic gas, is similar to methane. It's not useful for like normal cars. You cannot use rubber gas. Yeah.
There are development vehicles in India. People are actually running biogas waste from the agricultural residue.
Yeah, yeah, but that's a different kind of gas. Because that's similar to in English you would call it LPG, like liquid petroleum gas.
Yes.
This is more like methane.
And why is this difference?
In the chemical form of the gas.
No,
But
that
yeah,
I understand. But
Yeah.
what kind of agricultural residue are you using?
it's like wood byproducts.
So why can't you produce that gas?
Technical reasons, I don't know.
Oh.
I just assessed them.
Science.
Yeah.
Yeah, no, but
It's behind
I
it.
think they are reasonable questions.
It's different because LPG, you will obtain it from the anaerobic digestion of the this biological stuff. But this kind of very cellulosic stuff does not react well with biological digestion because
Sorry, I didn't get.
Huh?
What does that mean?
this kind of wood biomass
What?
has a lower productivity because it's difficult to digest. That's the idea.
I understand that. but,
Yeah, so if you produce by using that kind of material, if you want to produce LPG, liquid petroleum, you will have a lower production of energy. While in this way, it's more efficient because you will have more energy.
Do you have such data?
Huh?
Do you have such data? So
Yeah, I can give you some data
There is
after.
more of the choice, as far as I understood, and I worked on bioenergy before.
Hmm.
The choice is because of the infrastructure that is already existing for electricity
yeah.
or not.
Yeah. Understand, yeah. And, okay. That was this guy. And also there is also a little bit of production from photovoltaic.
There is space for a very short question.
Yeah,
No, maybe this is not the time to do the discussion, but So
I like
my-
more like this than
Okay,
adding all
I
the
wonder that
equipment,
if
yeah.
this is system is supposed to be like serving off the grid, no?
Yes,
But then if you have electrical vehicles, you are creating more dependency. Because electric vehicles,
Yes,
you have
that's
to
true.
extract
that's
minerals
true,
and all
that's
this stuff.
true. Yeah.
So I think there are a lot of trade-offs here and,
I agree with you. I
No?
completely agree with
okay,
you. This was in response to a project made by the park. The park wanted to develop some kind of mobility and to attract tourism. And they said, okay, we can have electric vehicles. How can we charge them?
okay. So it's not a
That's
big
the-
loss. It's not a
Yeah,
big
no,
loss.
no, of course, of course.
I have this one question about the diagram before, when it said deep heat, thermal heat, is that in,
This one,
yeah, is that
Yes.
in Naples as well?
yes.
Is that from Vesuvius?
Now from the Pontevedra.
Okay, but.
Pontevedra, it's
Another
volcanic
volcano.
area. It's
Volcanic.
maybe the more dangerous in Europe.
Oh,
And
Yes.
underground.
it's in the city.
The
It's a
more-
volcano.
Around
It's like an underground volcano
Okay.
in the eastern, no, it's in the
West.
western, yeah, part of the city, yeah, eastern Pontevedra. Yeah, it's very active area, and maybe you can, if you look at some news, you can also find the news about where this is in that area, like ground going up and down because of the volcanic activity. And you can dig 100 meters and have a lot of energy.
Yeah. Is that a good thing?
It depends.
Yeah, deconstructing Remo.
No, but I'm criticizing. I wonder about this as well. And it's not the high enthalpy
Yeah.
geothermal systems that in Italy, for instance, in Italy we have in Tuscany
Mhm.
a lot of high enthalpy geothermal systems. And they are also because of technical stuff, because you need to bring the geothermal fluid out and you will have a lot of emissions from it, etc. This is different. This is just a hole with a tube in
Yeah.
it, exchanging heat with water.
Yeah.
So it's different.
So it's not messing around.
No.
Thank you.
For all heat exchanger, we need some refrigerant.
Yes, there are some refrigerants also in
All
the
refrigerants are.
also in the ORC systems for the electricity production. There
That's
is
why heat pumps
yeah.
are never
yeah.
eco-friendly.
Okay. So, how do we assess this stuff? I use mainly by using two different methods. One is life cycle assessment. Life cycle assessment, like called life cycle thinking tools, which are life cycle assessment, social life cycle assessment, life cycle costing, etc. They borrow the concept of life cycle from biology. So you have different steps in the life of a product or a service. And these different steps are recognizable and are accessible. So you start from the extraction of the materials, then manufacture, transport, distribution, use, and then disposal. So we say that life cycle assessment has a cradle to grave approach, going from the extraction of raw materials to the final disposal. And in the last year, because of all these kind of reuse systems, the concept of circular economy is arising, etc. We also talk about cradle to cradle point of view by like we want to lower, the idea is to lower the final disposal of materials and to use energy material more and more. And a little bit of history about life cycle assessment. The first LCA study, they say was made by Coca-Cola in 1969. Coca-Cola wanted to know if it was better at the time to continue using glass bottle instead of plastic ones, because at the time plastic was more recyclable than glass, and the bottles was lighter, so you will have some benefits in transporting and distribution of plastic bottles. So they did the study, and this is the first SCA study. I mean, it's really coherent with the perspective of life cycle assessment. Life cycle assessment is very industry based and production based. Some important dates. So we have the first study in 1969, then the first peer-reviewed published paper in 1974. Then at the end of 80s and start of 90s, we have the first softwares for life cycle assessment. CETAC, which is a society of chemistry, because life cycle assessment, we can say belong a little bit to chemistry. And CETAC, which is an international society about chemistry, they are very active in developing the method, developing the standard, and how to practice life cycle assessment. They invented the term in 1990. Then we have the development of impact assessment methods that we will see later. And more important for me is 2006. There is the establishment of the international ISOs for life cycle assessment. These international ISOs, they are still valid now. They are updated, but we are still using 2006 ISOs. Tells you what to do, how to do it, and how to do it in a standardized way so that all life cycle assessment studies can be comparable one another. This is absolutely not true. I mean, because it's very automated in some steps, but the practitioner still can decide what to do and how to do it in some points. And that it's good because, I mean, you can perform life cycle assessment in the way you think it's better, but in reality, this shows the fact that life cycle assessments are not really comparable with one another. So these are the two standards. And this standard says that life cycle assessment is 4 steps to it's an iterative process, so you can go back and forth a lot of time. The first step is goal scope definition, which comprehends the functional unit of boundaries. In this step, you have to, there is a lot of questions, a lot of things to be addressed in this step. And they are about what to do, why are you doing, who will be the recipient, and how the results will be used. And in this phase, the functional unit is decided as well as the system boundaries. The functional unit is what does the system you're assessing produce. So it's a product, can be this month, or a service like electricity or mobility. It can be the functional unit. of your study. And why it's important? Because you will refer everything in the lifecycle assessment study to this functional unit, and to this is important also because enables comparison of different systems. And once you are working with the lifecycle assessment, you will learn that some functional units are, we can say, already decided. For instance, if I'm studying an agricultural process, like agricultural production of corn, a classic functional unit to be used is 1 kilogram of corn. So you will have the environmental impacts, because lifecycle assessment measures environmental impacts of 1 kilogram of corn. And of course, I could do like the environmental impacts of 2.5 kilos, but then it's not that easy to compare to other studies, because everyone is calculating impacts for 1 kilogram or for like the annual production of an hectare. There are some functional units that are better than others because are most used. Then you will decide the system boundaries, which are the physical or ideal boundaries of your production system. And this is important because at the interface of this boundary, the interface between your system and the outside global system, you will count what is going in, what is going out. So inputs and outputs, resource that comes in, and like emissions going out. These boundaries can be physical, but also geographical and also temporal. For instance, the production of 1 hectare of corn in 1 year. You can have different approaches to the study. You can apply a cradle to grave perspective, a cradle to gate, which, I mean, going from the start, from the extraction to a point in the supply chain, or you can start from a given point in the supply chain and stop at another. So you will have a gate to gate. This is really not important now. Then the second step, it's maybe the longest one, the hardest one. No, maybe not the hardest, but of course the longest is the construction of an inventory. You will need an inventory to perform a lifecycle assessment. An inventory is built by using primary data, so data collected on site, secondary data from literature, or when you use software, you of course use a software for doing an LCA, you will use data from a database. Or tertiary data if you have calculations and assumptions, etc. So this inventory will include, if we look at this as the system boundaries, what goes in as raw materials, resources, energy, what goes out as main product, possible co-products, and then all this kind of emissions in the air, in the water, and soil, etc. Yes.
Sorry, I don't do this stuff. Can we go back to the one before? The one with the cradle to grave and gate to
Yes.
grave and the
Yes.
stuff. End of life management.
Yes.
Where's waste in this? Like, is waste? Where does waste fit in this?
I mean, if, for instance, go back to the corn we talked before.
Yeah.
I'm producing corn.
Yeah.
So my product will be corn, but I also have a production of straw.
Yeah.
And that's can be considered like a waste to be disposed of.
Okay, so it's considered waste, even though that would then be a value for something else.
If you use This depends on on your system, on the economy you're studying. If it's used as a resource for like another system,
Yeah.
you can consider the straw as a co-product, yeah. And that would be different in the evaluation of the environmental impacts.
Okay, but end of life management then literally means something that would never be used by anybody else.
Yeah. Yeah.
Okay, so it's like dead.
Yes,
Okay.
yes.
No, it's just curious to me that you have these two like imaginations of like birth and death and then waste and.
Then impact assessment. This is where you use the software. Why you use software for SCA? Because it's easy. I mean, it's the most efficient thing to do and the fastest way to do a life cycle assessment. You can do a life cycle assessment by hand. I did it to some extent. A friend of mine did a complete, Silvio did a complete life cycle assessment by hand. Excel, yeah, not writing, but I mean, making all the calculations by himself. It's longest. You can have errors if you do like that. If you use a software, you reduce the possibility of.
What kind of math do you need? So what you do?
Essentially, multiplication.
Okay. So it's more like a modeling software. That you
Yes.
have modeling software.
Yes.
Say, this is the joule, the temperature,
Yes.
this
I
is the megawatt, whatever. Okay.
You build your inventory and you will have thought kilowatt hours of electricity, thought kilograms of this resource, thought kilograms of fuel, and you will have your product like 1 kilogram of anything, and emissions, thought kilograms of CO2, thought kilograms, et cetera, and you put it in your software, and then he will do the calculations.
So you say if you change these parameters, this will happen.
Yes.
Okay.
Might use also really graphs and
Yes, the software gives you the possibility to have graphs and images. I don't really like to use this kind of automatic created graphs. I prefer doing my own by using the results, not as use software. There are a lot of softwares that you can use. Some open source, like on OpenSCA. I used OpenSCA for a long time. Commercial ones, like there is a list there. What I use is CimaPro. And I can say that the choice of software is not really that important because the software is like a calculator. What is important is the database for performing the life cycle assessment. And the database, there are a lot of databases out there, a lot of free databases, a lot of paid databases. The most efficient one is called EcoInvent. It's developed in Switzerland. Switzerland, yeah. It's quite high price. I mean, you will pay like 5,000 euros for a license.
Okay.
Yeah.
Quick question. So just to understand the utility of the tool, if I want to know the impact in terms of CO2 emission of this,
Yeah.
and of course, if I know this is like a manufacturer, known manufacturer, so you will have a database in which you will see the data for this.
Yes.
Okay, where the oil is coming from, where the additives of the.
Likely you will go to the factory where they produce this kind of stuff, and you will ask them how much electricity you use, how
Okay.
much plastic.
And this information is public or is it like up to them to release it?
It depends. When you talk with like private companies, they will ask you not to
Yeah. Because
disclose.
seems fantastic on the paper, then in the real life, it seems very
It's
messy.
just like
So if
that.
I want to know,
Yeah.
if I want
It's
to do
just
the
like
same for
that.
Ence, for example, I imagine that me, Mario Pansera, are going to ask Ence, okay, so how much stuff you produce and what? They will, first, they will not let me into the factory. And then they will give me whatever data, how do
No, in my experience, they will give you the data.
Okay. So
And
there
they
is
are
no
willing.
legal boundary, legal framework to publish this data. They are
Yeah,
forced.
they will ask you not to publish the inventory.
But there's a legal obligation to do life cycle assessments and environmental
No,
assessment.
no. There's no legal obligation for lifestyle assessment.
Otherwise, nothing would be sustainable.
No, but that's the context of it, that people
Yeah.
use life cycle assessment to justify,
Yeah. Yeah, but I mean, there's a lot, I put them in the presentation in a couple of times. There are a lot like of environmental labels
Yeah,
that,
in the market on that.
yeah, you will go, even if you go to the supermarket and you buy stuff, there will be environmental labels. Most of them are based on lifestyle assessment, but there's no legal obligation to use them.
in Italy or, I mean.
No, I mean,
In Europe.
I thought.
no, I mean worldwide. I think worldwide.
In India,
It's all
for
voluntary.
environmental clearances, especially for forest lands, they do life cycle assessment.
Yes. I mean, okay, yes, you
Also
can have
for-
some,
For many other biofuels, they did hire multiple companies, did multiple things, including life cycle.
yeah,
assessment.
yeah. But
In
I don't
order
think
to-
it would be,
In
it
order
can
to
be considered like compulsory.
In order to produce standards, you have to use.
Yeah, but if you want to adopt standard, I mean,
Okay, well, we
It's
can
not-
look at it, no?
The policy of the European Union in terms of eco-label is that, of course, free market inspired ideology that say, if you are not obliged, but if you do that, people,
Your reputation.
people will buy it because the point is that there is no, I mean, how do you know if the
Even
lifestyle?
for things like bioenergy, which are more partially states of the project, because there's a lot of research that goes into that, and then eventually, I mean, in order to produce standards for making, for example, bioethanol agree with the current engine systems, you have to do certain kinds of assessment. Life cycle is one of them. So maybe not explicit, but maybe in order to produce certain kinds of standards or to have certain kind of clearances.
Yeah, but that's what he's saying.
yeah,
Maybe that's true for things that depends on life cycle assessment being a part, lots of production, no interest.
yeah.
And this database is always, because I try to look into this kind of things, the database, I have no idea how much I can trust this database. I trust in this database, and a lot of people are using it to
Yeah.
greenwash.
Yeah, of course,
Trust in this. So you said eco
Even
invent.
is the most,
Sorry.
Is the most trustworthy database.
no, I said that it is most complete.
Most complete.
The most excessive of greenwashing possible.
Yeah, possible.
Yeah,
Okay, great.
I have a question.
yes.
For example, when you were speaking about this thing that we could push or not, like you said that there is a lot of possibilities of adapting, the way you calculate stuff, like for accountancy, for example, if you produce like different stuff like bottles, like in accountancy, you can do the same, like even economically,
Yes.
There is a part of accountancy of cost. When you do accountancy of cost, there is a part that you have to allocate. So apart from this kind of autonomy to replace some of the emissions to one product to the other, do you think that the gap between the real pollution and what is estimated in LCI is not too big, or yes? You don't know? You know what I mean?
Yeah, I understand what
Like,
you
for
mean.
example, between what could be a real calculation and what they can calculate, just trying to calculate what they want to calculate.
Yeah, that's a really important point. And if you wait just a couple of slides,
Okay,
I
sorry,
can
sorry.
give you an answer. So, what do you do in this step? Or what the software does? You will have your results, your life cycle assessment results will be impact categories. These impact categories like global warming measured as kilogram of CO2 equivalents, for instance, or water use, like cubic meters of water used, etc., etc. And what the software does is taking all your inventory, and so all the input data, all the output data, all the emissions, it will select where to put this. So to which category we are addressing by using this stuff or by emitting CO2. And that's the classification. Then how much we are contributing to this category. So how much CO2, how many kilos of CO2 we are emitting. Not only CO2, but for instance, if we have methane, like emissions of methane, methane will contribute to global warming in a different way than CO2. So there will be some factors, like characterization factors, that will express how much we are contributing to that. For instance, a famous characterization factor for methane is 34 kilograms for kilogram of CO2 equivalent per kilogram. So if you emit 1 kilogram of methane in a system, it will contribute to global warming as if it were like 34 kilos of CO2, because methane is more active in global warming than CO2. So you will use this characterization factor to have characterized results. Characterized results are
compare things to make things comparable.
yes. And you will have so a list of categories: toxicity, water toxicity, freshwater toxicity, for instance, eutrophication, global warming, each one with a unit and a quantity. Of course, they are not comparable. You cannot compare global warming like kilograms of CO2 to cubic meters of water because different units. So there is an optional step, which is normalization. Normalization will express these results as number, as magnitude of this impact, as just numbers with no unit. So you can say, okay, in this system, the contribution to global warming is higher than the contribution to toxicity. But it's optional because it brings in a lot of uncertainty. There is an ongoing discussion in the LCA community about normalization. Some disagrees with the use of normalization, some agrees. For instance, I disagree with normalization because it's really a huge uncertainty that you are bringing in your study. But I use it for the sake of comprehension. I mean, I do a study, I write a paper. I can say, because there is this degree of uncertainty, I will not consider the normalized result as comparable to another study, because they will use like a different impact method, a different set of factors, different uncertainty. So they're not really comparable. But within my study, given this uncertainty, I can say that global warming in this system is higher than toxicity. I will not use normalized results to compare with other studies because there's too much difference in uncertainty, but I will manage that uncertainty within my study. And this is an example of impact method. You can have a lot of impact method in LCA softwares. Even different categories. You will have like environmental footprint, expressing only the CO2. You will have like just use of energy, etc. This impact method, the recycle, recycle, or they call it whatever. This one is one of the most diffused impact methods because they will give you results about a lot of different categories and different environmental compartments. This is to answer what you were asking before. If you have results, you have kilograms of CO2, etc., etc., etc. How you can rely on them, it depends on what the practitioner decided to do once having the results. How he managed to take decisions in these consequential steps where he could make decisions. So a good thing is to always disclose what you're doing. I did this because I did this because, and this is really important in the analysis of results, because once you have, if you have co-products in your system, you can assign, you have to divide the impacts among them. I will not go into the details because it's really going in separating the splitting the air. Okay, but these are ways to divide and assign a part of the impacts that you generated among the products. So if you have a study saying that 1 kilowatt hour of electricity produce this amount of CO2, for instance, you have to always keep in your mind that maybe it's not the total amount of emissions that you have in the system. So, to answer, you can rely on HCA results if you have a paper or etc. If they disclose everything, and it's really difficult, it's not happening all. I would say that it's never happening. Never happening. No one discloses fully what he did in a study.
Because of privacy also.
Because of privacy and because of accountability. If you say everything, you take responsibility for what you say.
Yeah.
A lot of LC practitioners don't do that. And these are some labels that are based on the cycle assessment. So that's what we were talking before. In order to get this label on your product, you will have to perform a life cycle assessment of your product or your service.
But you do that, or there are companies that do it?
No, these are made by companies.
External companies.
Like, for instance, in Italy, there is Accredia.
They are consultant.
Yeah. Maybe they will ask practitioners or universities to check the calculation or to provide assistance, but they are private companies. And to get this label, this is really important to me, to get these labels, you are not forced to improve your system. I mean, you are not forced to say, okay, I'm emitting this amount of CO2, next year I will emit less. No, you just need to perform the analysis of your system and say, okay, I'm emitting this, and this. And you get the label.
The company chooses the location or not?
So you just. So if you are a steel producer with coal, it's fine.
Thanks
Yes.
for taking part. You know?
Yes. Yes. The thing is that if you apply to one of these, very likely the information will be public. You can go on the like EPD, which is the one of the most diffused in Europe. You can go on their website and check the emissions for each company that applies to the label.
And then like benchmarks.
No.
Oh, you just pay, you get the label.
You pay, you get the label. Yeah.
And the company,
But you are disclosing your emissions, your impact.
and when they calculate, do the company have some autonomy in the decisions on how to allocate?
No, the calculation is not performed by the company itself.
Yeah, but for
There is
example,
an external body that perform the and give you the certification.
so the principle is that they are at least aware of
Yeah,
the,
of what
that's the
yes.
objective of the
Yes,
certificate.
that's the idea. They are aware of their impacts, they're disclosing them.
Where
Because
they come from.
once you apply to you are disclosing and you are making your impacts public.
Hmm.
And okay, so that's for the lifestyle assessment part. The other method that I use is Emergy. These are completely different stuff. And to some, like to Andrea Genovese, this is magic. This is not science, this is magic. Okay. Emergy is another environmental accounting method, which are completely different and opposite perspective. If lifestyle assessment is industry oriented and consumer oriented, Emergy is as a like biosphere, let's say.
Biosphere oriented.
Yeah, but how much the biosphere spends, how much it contributes to the production of things, of services or products, etc. This guy is our Theodum, which is the guy who developed the method, starting from I would say from the 70s, but the first real development of the method was in the 80s and the 90s. He was an ecologist, brother of Eugene Odum, another ecologist. They wrote a lot of books together. And basically, energy accounting considers the work done by the biosphere to generate resources. And it's tied to the concept of energy quality. So the different ability of doing work of different forms of energy.
Entropy, basically.
Huh?
Entropy.
Exergy. Yeah. It's based on exergy, which is the available energy in things, like in energy in matter, the fraction available to do work, so to make transformation process happen. And in this way, you have a donor side perspective, and energy is considered also as an alternative theory of value. Like today, value is, better than me, that value is just considered, mainstream is just considered as economic value, like willingness to pay and how things cost, how much they cost. Like here, we as energy practitioners, we are proposing it as value based on the ecosystem work to provide things.
Sorry, before we go further
Yes.
on this, can I ask a question over LCA?
Yes.
So does any of the LCA consider where things are happening,
Yes. Yes.
where things are mined and where things are
Yes.
producing?
Yes.
So that
Yes.
information is there.
Yes. And also in
Consider that is a
databases, you will
different-
have,
Is there a, when you finally come up with numbers, it's anywhere the where can go in? Is that used? Where something mined,
yeah, you will have that.
how do you do that?
The databases will, if you go there
Yeah.
to collect data, I mean, you are doing it, so.
No, I mean, if cobalt is mined in one country compared to another country.
Yeah, I understand.
So
So if
how is
you,
that information coming out in the final number?
it's coming out because if you use like databases process, like you take different production process from the database, it will be different based on the countries. They will have a different different energy mix, like for.
Yeah, but there is also a lot of qualitative,
Yeah.
qualitative data and metadata that are not available. And this is why we have a project called because normally it's 40 minutes. We already have one
Sorry.
hour.
We interrupted him a lot.
Yeah, it's true. It's true. Don't worry, but come.
Yeah, sorry. And so energy is defined as the, we already said that, the available energy for transformation, and we compare that to the solar one. So the unit of energy is the solar and joule, and you will have conversion factor to transform this exergy coming from energy and products into solar equivalent joules. So all natural and socio-economical systems are interconnected in a network, and going farther in this network, quality intended as complexity of the system will rise, going from one step to another. So you will have increasing UV factors. There are a lot of books about this, are very interesting. So if you want, I can share something with you. And the perspective is called, Automobile used to say that Emergy applies a macroscopic perspective to look at systems from the next larger scale, because science, we all know that, is very reductionist in some aspect. But it will say the whole is greater than the sum of its parts, and the missing information is not in the microscopic components. So he wanted to apply a wider perspective when analyzing systems and ecosystems. And it's based on the idea that all systems go through this pulsing paradigm based on the availability of resources. So you will have a first stage of growth when resources are abundant, then a climax when resources are becoming scarce, then you have a descent in the system because there's no resources, and then the restoration, and then the cycle goes back. This is very.
Where are we now?
Odom would say that this is one thing I don't agree with him, because he said that on a global basis, we are in a climate descent kind of situation. I would say that this is true for Western societies, not on a global basis. I mean, Europe, US, we may be in a transition stage, but I don't think it will be true for when talking about a global situation.
Yeah.
I mean,
But what? Okay.
yeah,
But if we outsource all of our stuff. no?
yes.
Yeah, so then we are not, like, if we like accounted for that, then we would also not be descending.
Yeah,
Okay.
yeah.
Okay, so we're still in the growth,
I don't know.
according to you.
No, according to me, we are full in
Okay.
climax situation.
So we are still here.
Here on the verge of descent. Yeah.
Until we get to 2050, isn't it?
Yeah.
And it's just all downhill.
So we are looking at the abyss, and the abyss is looking at us.
Yeah.
What did they say in limits to growth? 2040.
Okay. And calculation, we consider local renewable sources, local non-renewables, and imported non-renewables. This will include also labor and services. The services are intended in Emergy as the indirect, it's a measure, a proxy for indirect labor. All this stuff is calculated based on global energy baseline, which is the energy driving the biosphere per year. And you will calculate a lot of different indicators. The most important one is U, which is the total energy of a system, of the system you're studying, which is an extensive indicator giving you the size and the environmental load of the system, while UAVs, which are the conversion factors, are intensive indicators expressing the complexity of a given input or a given kind of energy or kind of matter. And then you can calculate whatever based on these indicators, measuring sustainability, the percentage of renewability, etc. There are a lot of stuff very interesting. Like Chinese group is very good in calculating energy for nations. They're calculating the energy for each different nation and calculating the load of the national economy on the global ecosystem, the energy for one unit of like for $1 for each nation, etc. So it's very interesting. This is the kind of system diagramming that we use in Emergy. I will not go into detail, but it's very useful to visualize your systems. It will go from lower here complexity to higher complexity here. And they're very useful to assess because it's analysis of, it's a kind of analysis of stocks and flow. And so it's very useful to visualize it. You will have some particular algebra rules when doing it. And this is just to show that we are a very small scientific community. A lot of Emergy practitioners are based in China. In China, they use, this is interesting, they use Emergy also for like bureaucratic stuff, like for policies and also for, yeah.
To make policy.
Yeah.
Public policy.
Yes. And I didn't know that. I knew it recently. United States is another big point in energy because there is all the stuff connected to the University of Florida and to the group of Odum. We have a couple of groups in Italy doing energy and in Brazil, while in the rest of the world, we are experts practitioners using it.
Why so big in Italy?
Because
Sense.
yeah, because of Sergio Giadi. Sergio Giadi, which was my tutor for my PhD, he was direct, come si dice, he was a student under Odum. And then he had a research group in Siena. Then he came to Naples, and the group in Siena continued doing energy. Then he came to Naples and we started the research group there and we are doing energy. There is Pier Paolo Francese, which is the coordinator, the PhD, is also my PhD program coordinator. And we have a guy in Venice that contacted Sergio Francesco to know about this. So Yeah, it's because Italy is because of Sergio, yeah. And then just to finish, what I did is trying to combine and to integrate the methods because basically they are performed in the same way. You have an inventory and you multiply it by factors. They have, and this is interesting because the two methods have opposite perspective. One is donor side, one is consumer side. And one is industry, FCA is very industry based, while EMA is ecosystem based. So they are, and this is not something coming from me. Like a lot of researchers are trying to combine and integrate the methods. And what I did together with some colleagues in the lab, we developed this procedure for analyzing the system by using the two methods. So starting with an LCA to understand the hotspots and the impacts of the system. Then we built some scenarios by using Emergy, and then we tested these scenarios by using FCA at the end. And this is an iterative process, and yeah, we are trying to do things to make these two things work together because they're really connected and they're really complementary. So it can be useful. And another thing I did for the integration, one of the problems with the Emergy is that it's still very much in development. So there is no standardized procedures, there's no databases, there's no shared databases, etc. So in order to have reliable conversion factors, I tried to use the LCA databases as a source of inventories in order to build energy conversion factors. And this is something I did in the last couple of years and producing some good results. And that's it. Sorry for being too long. And maybe too much of your time.
No, that's fine. What, any question, other criticism? Maybe.
Do you think Emergy is a better way of understanding?
I will not talk about better or worse. It depends on what are you looking for. The two methods will give you different answers.
So just, I know something, just to want to provoke some debates. So imagine that you are applying energy to corn, like
Yes.
in our example. So you will be able to measure the quantity of labor that bees is offering to pollinate the plants, for example. And where is the limit? Because then the labor is provided free by the bees, but then
Yes.
the bees needs other forms of energy, right? And then,
Well,
so how do you where you put the boundaries? Because
I think that this particular kind of consideration is practitioner based and system based. I mean, if we are
so we decide what is in and what is out.
yeah, but because bees may have a more relevant role, like in the natural production of corn, while there will be not so much used in like an intensive farming process.
Okay, so I'll give you an example.
Okay.
I work for a factory.
Yes.
Okay, so I have to sustain myself, I need to reproduce myself. Okay, so it's not just eating.
Yeah.
It's also about maintaining social relation.
Yes.
And if I go to the factory and I cross a wood, for example, a forest, my mental status is better and I will be more productive. How do you do this with them?
Yeah, this is very interesting, and there is an ongoing debate on this. For instance,
So this is measurable.
it depends on what you consider measurable. I mean,
No, because at the end of the day, I mean, I understand that this is much better process because of the philosophy behind that.
Yes.
On a practical basis, still a lot of problems remains. That is
Yeah, of
what
course.
Poonam was saying about the politics of resource allocation and choices. At the end of the day, it's not about how you measure stuff, it's how you do, how you make decisions
Yeah, that's
about
yeah,
what to
yeah.
measure, right? And this
But
is,
that's true also.
so you need
for-
social scientists to do that. You don't need.
Of course.
engineers.
Yeah, I mean,
So do you agree with that?
yeah, I completely agree with that. This is very, I'm in the last year, I've been working on the how to consider labor, because you saw that we also include labor and services in it. But what does it mean? I mean, a lot of, and this is also because there's still no standardized procedure for performing energy accounting. A lot of practitioners will include labor by considering the salaries. So how much labor are paid, and you will put that number in your accounting. And for me, this is maybe the most horrible way of doing this, because of a lot of things like economic fluctuation, the value of money, and also maybe the guys who work in your system are not paid enough or are paid too much. So it's not really a good way of measuring labor.
Let's say, sorry to interrupt it.
Yeah.
It's not the only thing that you should consider when you talk about labor, because, for example, I don't know, also social SCA tries
Yes.
to give this kind of social perspective to something that is engineering stuff. But, for example, there is labor which is not even considered just because
Yeah.
it is not paid. Not
Exactly.
labor of people working for producing this, but all the things that are behind them. For
Exactly.
example, care work that is not even considered in the numbers that you.
So we have care labor in energy accounting.
No, I mean, that was my reasoning here. I would, for instance, I'm not considering how much they are paid. I'm considering, and by considering, I mean using a conversion factor related not to the money, but to the people involved.
Mm.
And this number, this conversion factor, is built by considering how much calories a human have to introduce for sustenance, how much energy is, on average, of course, needed for education and that kind of stuff. And to include, for instance, care of work. You can, I would say you could do it by including a larger number of people in the assessment. And you cannot do it by using how much people are paid. So that's why I say just looking at salaries of people involved is the most horrible way of considering labor. I would prefer to, and that's what I'm doing, to include a number of people that are involved
Okay.
directly or indirectly in the process. But still, this is an ongoing debate also because of there is a huge debate of energy related to information. Because how do you consider what's information? And Mark Brown is he was a student on with Odum, and is maybe the most big personalities right now in energy. He would always give you this example of catness. You have an ecosystem, and you have a cat, like a panther. You have live panthers in this ecosystem, and they are regulating in some ways the ecosystem. If all the panthers dies, you still have, for some years, the effect of the presence of the panther, the catness. You still have the effect of this catness for many years after the
Distinction.
disappearing of the cat. But how you consider that information? So this is still ongoing. There is a lot of things still ongoing in energy.
Mm. Yeah, this is path dependency and all this
Yes.
stuff, memory of the system.
Yeah.
Okay, so thank you very much. A lot of
Thank you.
mental food to digest or to process. If you want to use your language. And I don't know if there are any other questions. You will be around
Yeah, I'll be
for
here,
weeks.
so-
So if you want to know exactly how to calculate your energy as a person, ask Remo.
Sergio and Mark would like to calculate the energy of the Vatican City. Why in line to enter Vatican
You
City?
can calculate the energy of a heavy metal community
Yeah.
that is collapsing, I think, within this the center. Okay, so tomorrow we have the rejoin, sorry if I pronounced correctly, Ringe. And he's from University of Edinburgh. He's an engineer, telecommunication engineer, but he's trying to convert to social science, right?
I don't know whether I'm trying to convert the world.
So he's struggling to convince engineers, students to be more reflexive. And yeah, tomorrow we will talk about decolonial ICT. And I think you have the abstract. And okay, so welcome. He'll be here until Thursday. So feel free to approach him if you want to know about how to produce a microchip and how unsustainable is the ICT system. And yeah, he will be in the conference in June, no? You're coming, probably.
Yeah, probably. I don't know whether still. I mean, we have to write the paper.
Yes, we need to write something.
Yeah, we have to write.